Okay, this is the second section on electric current. And current is something that you might be familiar with. This is kind of how electricity flows into your house, how it flows into any of your appliances that you use. And the reason why you're able to get electricity to them, to power them, is through electric current. So this is the continuous flow of electric charges through a material. Usually you'll need something like a conductor, which we'll talk about later on, to kind of help you, get those charges to pass. The unit of current is what we call an ampere or an amp. They often shorten it to amp. So it's how many amps of current something has going through it. And in order to produce that electric current, you need to have a continuous flow of charges from one place to another. So charges have to flow for electricity to work. When you stop that flow of electric charges, something cuts it off, or something you no longer have a current flowing through, you're not going to get electricity to an appliance. So you need a continuous flow if you want something to work. Okay, so the first picture here, the guy with the tomatoes on the conveyor belt, it's kind of showing you, and I guess this is kind of a little off of me. I can't remember it right now. But it depends on how quickly that conveyor belt is moving, whether, how much current is flowing through it. It's kind of just showing you how current works. So if there's less current flowing through, there's less tomatoes going past the guy. Whereas on the one on the bottom, the tomatoes are going by faster, so there's more current, basically. So the more current, the more charges can flow through something. So here there's just kind of a regular amount of current. We put more current into something, then it's going to have more charges passing through each unit of time. So depending on how much current you have flowing, that's how many charges. This right here is a circuit, an example of a circuit, I guess, just a kind of a visual for you. This is a complete unbroken path through which electric charges can flow. So it needs to have, if it's broken at any point, that circuit, then the electricity is going to stop flowing through it, which is what happens when you turn light switches on and off. You either get the current going back through something, you complete that circuit, or you cut the circuit off so it stops the electricity flowing. And that's kind of how an electric circuit works. It needs to have a continuous path. It needs to have a full path that is unbroken. Okay, so I mentioned this earlier, conductors and insulators. If we want some charges to flow through something, we need conductors. Conductors allow transfer of electric charge because they allow electric charges to flow through them. They're used to carry electric charge, so things like metal and wire and things like this. These are pictures of conductors up here. They allow electric charge to flow through something. If you've ever touched a conductor while it's transferring electricity, you'll get a shock because there's electricity flowing through there, and that electricity will flow into your hand or whatever, or foot, whatever you touch with it. Because it conducts electric charges, it allows charges to flow through it, which is why usually your stuff at home, like you have wires at home, they're going to be covered with plastic, because if they just had the bare wires exposed, which are conducting the electricity, you get shocked all the time. So the conductors allow for that charge to flow through them. And the other part of this then is insulators. So the exact opposite of a conductor is an insulator. Those do not allow electric charges to flow through them because they can't flow. They can't flow through easily. So they stop the flow of charges, which is why you have that plastic around your wires. Most places are going to have that. If you have exposed wire, you're asking for a shock. If you have an insulator around your wire, plastic is a really good insulator that will keep that charge from flowing through and shocking you. So electric charges can flow through the conductor inside the insulator, which is the wire is the conductor inside, the insulator is the plastic that surrounds it. So down here are some examples of insulators. Especially this wooden spoon here versus the metal spoon, which is a conductor. If you've ever used a metal spoon versus a wooden spoon to stir something that's hot, if you touch the metal spoon after it's been in the pot for a while, you'll feel that it's hot because it's conducting that heat. It's a conductor that conducts heat, electricity, whatever, whereas a wooden spoon here does not. So wood is not a conductor. If you use a wooden spoon in a pot like that, those charges or that heat is not going to be conducted through the wooden spoon. You're not going to feel that same heat. Plastic is a really good one. Rubber is another one. So several different some examples of insulators that are used to basically protect you from that flow of charges because they don't allow charges to flow through them. Okay, then voltage is another thing that helps current to flow. So the more voltage you have in something, the more current that's going to flow through it. We talked about current. If it's faster, there's more current going through something that's going to cause the charges to flow past. That all depends on the voltage, because this is the difference between that causes that current to flow. So if we have a larger voltage, which is kind of like that source of power for the electric current to flow, then we're going to have more charges flowing through an electric circuit. So you probably heard of voltage in batteries. You know, the more voltage you have for a battery, probably the bigger appliance you're going to use. And some of them use bigger batteries than others. Some voltages, some smaller things don't take as much voltage to work, but some things take bigger amount of voltage. So that depends on the size of battery that you're going to use for them. So things that need more power are going to have more voltage behind them just because they have to produce more current to go through it to allow that thing to work. A voltage source then is going to be the device that creates the source. So the voltage source would be like your battery, or maybe your outlet would be a place for that voltage source to be as well. And those allow for that current to flow through a circuit, which allows for an electric appliance to work. Okay, then resistors are also a part of this. Resistance, basically how difficult it is for charges to flow through a material. So it doesn't mean it's like stopping them, but it slows them down. So sometimes you'll have resistors on things that help, like maybe there's a lot of current coming into something, but we want to slow it down a little bit so you don't have too much current going into certain appliances that don't need as much. You'll probably put some sort of resistor, something that causes resistance. So resistance is the measure of how difficult it is for charges to flow through a material. If that's something that's greater resistant, there'll be less current that will flow through for a given voltage. So they're just showing you a couple examples of resistance here. If you have a wider, this is wider pipe in this case, but if you have a bigger wider wire, there's going to be more current that can flow there versus a narrow wire, or in this case, a narrow pipe. A short versus long, if it has a longer distance to flow over, it's going to flow a little bit slower than when that's a little shorter. So the same amount of water is going through it, just has a longer distance to flow through, which means there's more resistance with the long versus the short. Same thing with any sort of like wire or something that produces a current. Resistance is going to basically affect how much charge is going to get through that particular wire. Okay, so there are also some other things that affect that resistance. So it's the material that makes up the wire, the length of the wire, the diameter, and the temperature. Material, there's some different wires or different types of wire, different types of metal that make up wires. Some of them allow more charges to flow through than others. So depending on what type of material you use for your wire is going to determine how much electricity can flow, so you might have more resistance versus not. We talked about length and we talked about diameter, but temperature as well. So hotter wires are going to allow more charges than cooler wires. So both of those, if you have something that's cooler, it's going to definitely impede or resist that flow of charges. This is an interesting one because I often, this is brought up in the book, and I thought it's always interesting to talk about. But a lot of times, you'll see birds or squirrels sitting on a wire, and you're like, well, those wires are exposed because all electric wires that are up above us, they don't put insulation on them because they're up above people. People aren't supposed to be touching them, which is why they always say don't touch a downed wire, because there's probably still electricity flowing through it. But anyway, this bird here is sitting on a wire, and electricity is flowing through that wire. And why isn't he getting electrocuted? Because he is he's sitting on something, he should be shocked. Well, the wire actually in this case is the path of least resistance. The charges are going to follow that path of least resistance. They want to flow more. So if there's a way for them to flow and not be resisted by something, they're going to flow that way, which is why you don't see squirrels and birds getting electrocuted when they sit on those wires, because they are not the path of least resistance. It would take more. They offer more resistance than the wire itself, so the electric charges are just going to continue to flow through the wire and not into the bird. All right, this is the end of the second section from chapter 2. Again, same thing. There'll be the notes. These are the notes, but the reading material will be posted in PowerSchool Learning, and the worksheet that goes through this section will also be posted. You can either pick them up at school, you can print them off at home, you can just use the worksheet and just insert it on a piece of paper. If you do that and want to just take a picture of it and send it back in to me, that would be fine. Or you can drop them off at school as well. So enjoy!